All right, everyone. Welcome once again to the Faces of Your Business. I'm your host, Damon Pistolka, and man, am I excited for my guest today. This is a guy that I've known since I didn't have gray hair. So I'm excited to get to talk to Sean Mertes today, and we're going to talk about technical sales with application engineering. And really, this is super interesting to me, and I know that a lot of the manufacturing people here that are listening will understand what we're talking about. But I'm just going to let Sean start in on this. And first of all, I'm just going to say, Sean, thanks for being here.
Absolutely. Thanks for having me, Damon. I'm excited to be part of your show.
Awesome, dude. Well, we started eons ago in injection molding.
Yeah, what was it? 1990.
don't even talk about it, man. It's like it's before Prince was popular, man.
I know.
Because you're in Minneapolis, and actually, Dave Meyer, a guy that I know there from the cities who does digital work, he actually is one of the guys that built one of Prince's websites. So
wow.
One of his later ones where he was actually selling music on it. So that's what it got me thinking. And he was talking about that last week. We interviewed him on our Friday show. But so you've been in the plastics industry for quite a while, Sean. First of all, as an applications engineer on the plastic side in a molding company where we worked together and we started out of college. And then you started working for plastics companies that actually develop the plastics themselves that are used by the people that are molding products. And you've been in that ever since.
Correct. Yeah. So, we went to college, South Dakota State University. We both worked at the same place. I was there for a little over 6 years. Did a little bit of everything from molding to design. And then I went to be a tech rep for a large distribution company. And it was my job to make things run quickly, smoothly, bigger, better, faster, stronger, and do a lot of training. So I did that for about 10, 12 years, and then moved into application development and kind of moved into sales / application development with a smaller company. And then that smaller company was bought by the company I'm with right now.
Very cool. So it's interesting that you've seen the molding and the production setting in the beginning and at Falcon Plastics where we worked together. And then as you were training people and tech support and trying to help them solve these problems in molding, were you actually in the field then watching things being molded and helping them make them run better? Or what were you doing when you were doing that tech support?
Yeah. So when I was at Falcon, the nice thing is it's a big company, but a smaller company, and you have certain customers and you get to see what you get to see. So you don't get to see all the stuff that everybody does and all the problems. Yeah. So when I left there and went to work for the distribution company as a tech rep, it was overwhelming for the first 2, 3, 4, 5 years, because basically when we were at Falcon, if I couldn't figure it out, I would call my guy, and my guy back in the day, his name is Mike Van Dyne, phenomenal guy, good friend of mine still, and say, Mike, come in and help me fix the problem. Well, guess what? I went from being the guy that, tried everything and then called somebody in to the guy that got called in. Like,
yeah.
Wow. Now I'm responsible for a couple $100,000 tools. They've tried everything. All right, Sean, fix my problems. Sometimes it's not so easy. So unfortunately, most of the times for tech service, we don't get called in for handshakes and don't get called in to go golfing. We're called in when they're up against a wall and they need answers.
Yeah, that's true. So when you were in that role in the tech support there, did they have good people that could help you if you couldn't figure things out, or are you pretty much sitting there to go back to the basics of physics and everything else and just kind of figure it out that way?
A little bit of everything. Back in the day, a lot of the suppliers had their own internal tech reps that I could call. Back in the day, they had a 1-800 dial and a 1-800 DuPont for their inside tech line. I remember DuPont, her name is Nancy Eckrich. it's weird. I probably could still remember the phone number, but I could call them and they'd put me up with the right person. Nowadays, everything is being, working from homes, cost savings. A lot of the large suppliers are relying on distribution and the manufacturers such as ourselves to be the leaders in their plastic. So back in the day, there was a lot. But as you know, when we started, we had computers, but Google was probably Google, but not what Google is now.
Yeah.
I remember learning some of the stuff and, writing the papers and term papers and stuff. We had to go to the library and do research and stuff. Now everything's at your fingertips.
Yeah.
So if I want to learn something or do something nowadays, you can YouTube and figure kind of pretty much a lot of things out. Back in the day, there's a lot of networking where it's not what you know, it's who you know.
Yeah.
And, things have changed. So it's been an interesting road to see how it started with. I remember we had a big catalog out in front of our offices that we'd put everything in. And here's this stuff. Here's for polycarbonate. Here's ABS. Here's PCABS. We had drawing guides and sheets. Nowadays you buy something. I just bought a generator. They don't even give you a book anymore. You just look it up and you print it.
Yeah. Yeah. So this makes it's a good point. So now if I'm sitting here as an injection molder and I'm having a problem, does YouTube have videos on solving, an ABS kind of problem? Do you see that kind of support kind of stuff on YouTube now? I never even thought of looking for that kind of thing.
Yeah, they do. There's a lot of stuff like back in the day. They still have a couple of them, like online training classes that you can pay for and you can do. But there's troubleshooting. I don't know if YouTube necessarily, but there's a lot of stuff on like troubleshooting black specs. Check your back pressure, check your temperatures, check this. A lot of presentations that anybody put on. I'm a member of SPE, Society of Plastics Engineers, and I'm actually a program chair. But when you're a member of SPE, you can go in and see it. So I can go back and I can see all kinds of old presentations. So I have presentations that I possibly put on. And then you have access to the seminars and you can download them and it's all at your fingertips. So much now.
Yeah. I never even thought about that. And that because it is so much more available to you and so much easier to access if you know where to go.
The funny thing is I've talked about this back in the day, SPE, you'd show up and you'd pay $30 and you'd get a dried out piece of chicken, network for a while. And then you'd have a speaker come and talk for an hour or so about things. And you'd network. And it was basically who you know. Nowadays, I was talking to some of the younger SPE members and I said, you don't network anymore. Like, well, I don't need a network. I can be on a computer. I can do this. I can see anything at my fingertips. For me, there's still something about school of hard knocks. I would rather talk to a mechanic or talk to you to go, hey, Damon, I'm having this problem. And you say, hey, try this, as opposed to Google, because anybody can put something on Wikipedia. Anybody can put anything on the internet. Is it right? Is it wrong? It's their perception. And I suppose even if you're talking to somebody, it's their perception of right and wrong. But if it's someone I know and trust, I know I'm going to trust it a lot more. I still go back to a personal relationship.
Yeah.
Because
and then, that's funny because you say that it's changed for me a lot over the past couple of years, especially as we got stuffed in our houses the past year and a half or so with COVID, and our business going virtual even before that. But still having at least a video connection like this, and then meeting people in person when you're in the area or something works really well, even for a troubleshooting kind of thing, because you talk about technology, and last year we sold a business that we never met the owners in person. We never saw the business in person, and the buyers of the business never visited the business because of COVID. And we did things with video. We did, not stupid, but we used whatever what's the iPhone? FaceTime. There we go. We had to FaceTime, go around. Here's some inventory, counting the inventory, looking at the machines, all the kind of stuff. It was wild to do that kind of stuff. And so they, kind of off on a tangent there on that, but the ability to be able to connect with people that can help you or that you can help is really something. And I think that the younger people that are coming up are probably utilizing maybe LinkedIn more or Instagram or something like that with the network of people that they've met, could be digitally, but that they know are in the same industry solving the same problems.
Absolutely, absolutely. And nowadays with technology and shipping and Amazon, there's really nothing you can't get very quickly. And if you want to pay for it, it can, you can get some from California next day air.
Yeah.
And it's no big deal. It was a lot harder back in our day.
Yeah, that's for sure. So when you're out here now, though, you talk about you were doing this tech support and you're having people calls. Now, when you're working with application development, talk to me about a typical way that you're going to help a customer find what they want. One of your where you have to work through the solution to the problem and get them down to the end result.
Okay. Well, first off, I think the main question is, have you been doing it in the past? Is this something that's existing and you're trying to make it bigger, better, stronger? Is it brand new? Is anybody else doing it? Let's say that, you want to make a four-wheeler. You're not going to start, from scratch on building a four-wheeler, because back in the day, they had the three-wheelers. The Honda Big Red was the deal. Then they went to four-wheelers. Now they're at side-by-sides. And you're not going to start all over. You're going to say, okay, what are they currently doing? What are they currently using? Automotive, there's some information that's out there. It's amazing how just on the computer, I can say, show me all the vehicles that are out there. And I want to know the EV batteries. I want to know the components of the EV batteries. And there's pictures. They blow it up and they say, this one's made out of polypropylene. This one's made out of polycarbonate. This one's made out of this. And you can see, and reverse engineer a lot of stuff. So that's one of the ways to do it, is say, hey, can I reverse engineer it? Number one. Number two, if it's something new, to say, hey, I'm making something, nobody's ever made it before. It's not out there. Then it kind of comes down to, okay, what kind of properties do you need? Does it need heat? Does it need UV? If it does need heat, how hot and for how long? Do I need to worry about, RTI, continuous use temperatures? If I'm talking outdoor, do I need UL ratings like F1? F1 rating means it's been set for outside so many hours and it maintains its physical properties. Or does it just need to look good? If I'm making a patio chair and it's throwaway disposable, I don't necessarily care. But the big question is just asking them to rank the criteria. I want clear, chemical, and under $1 a pound. Well, there's certain criteria I can do and certain criteria I can't. I can get you clear and I can get you some chemical resistance, but under $1 a pound may not be possible. Some things go hand in hand, some things don't. And especially now with the resin crisis and everything the way it is, you can't get your hands on anything.
Okay. So I was just going to ask, the supply of plastic is tight, like steel and everything else that people are trying to get on.
Absolutely. And it's funny because if we look back, we've had seminars talking about this. When COVID started, nobody knew we knew what COVID was, but we're like, how's this?
Yeah.
So we have all kinds of inventory, or suppliers and manufacturers have all kinds of inventory. All of a sudden they start shutting companies down, and we're saying, we don't want to get stuck with millions of dollars of inventory.
Yeah.
We need to sell it off. I need to get rid of it. But in the plastic industry, people got shut down and automotive shut down, but it kept trudging forward. And because it got shut down and we ditched all the old inventory, then we had that cold snap that came through. I can't remember exactly what they called that cold snap that actually froze down in Dallas, Houston.
Yeah.
Manufacturers, they lost electricity. And because they lost electricity, all the fracking and all the pipes and everything froze.
Oh, yeah.
You gotta start from scratch. We have pictures showing these cracked pipes. And the problem is you can't just fix the pipe that cracked, because you don't necessarily know, is the other one that's right there that you just got done fixing, is it structurally damaged? So basically, you got to start over. If you're tearing everything apart, might as well start from scratch. Then you can't be within 6 feet of somebody else, so you're working by yourself. Imagine carrying these big, huge pipes and trying to do things with mass up in the air. It takes years and years to get these built, and they had to go in and rebuild them just very, very quickly.
So
So
we're talking about the plastics production facilities,
yes,
the materials production facilities, because I never thought of that. So yeah, I've got a couple friends that are in the Dallas area, and they were lucky enough to have generators, so they didn't, have everything frozen. But
right.
that has to be a mess because people don't. Well, plastics are made from the byproducts of refining oil, and then down the line it gets processed many other times and turns into plastic. But I never thought about how that would affect it because a lot of the plastics are made down there around refining areas.
Absolutely. And a lot of it too is just with COVID, you can't have plant operators standing close to each other. You can't do this. Then you kind of shut down. Nobody knew what was going to happen. And now everything's on force majeure. Everything's on allocation. So if we do have access to it, everything that we bought last year, they're only saying you get 60% of everything you bought last year, 70%. We get a percentage, and then you have to divvy that out and make it work.
Wow.
And
wow, that's something. That's something because it is really interesting how that's hit all the industries. I mean, how it hit the housing market with the lumber prices, and then it moves into everything else, and it's because of the sharp drop and then the sharp ramp back up.
yes.
And it's interesting how that's affecting everyone because I know earlier this year, the price of steel and sheet steel and everything was almost to the point to where you couldn't even get quotes. It was like, this is the price of the day kind of thing for them. And so did you see that the price of plastics going up like that too?
Absolutely. Yeah.
Okay.
It's phenomenal how much the price of plastics, I think every day I get 2, 3, 4 price increases, and it's just going up and up. And it's just got to a point of everybody just kind of knows it is what it is. And it's the same thing. I mean, I'm technical sales, so I don't necessarily quote every single day and the pricing as much as a true salesperson does. But some of it is we have what we call a Christmas list to say, if you want plastic and you haven't bought before, or there's no allocation, put your name on a list. At least you're on a list to get something. But we can't guarantee dates. We can't take delivery orders. We can't guarantee anything. And then when or if we can get it, we're going to do everything we can to work with you to get you what you need. But we can't guarantee pricing, and we'll tell you what your pricing is when we get allocation and we get what to come in.
Yeah. Yeah. That's wild, dude. Cause that's crazy to think that we've got, it's at a time where you cannot get it.
Right.
It just anything really. I mean, when was the last time you and I were around when you couldn't go get something? I mean, like anything.
And that's the funny thing is a lot of times there's certain things, but like, the toilet paper shortage, you couldn't get toilet paper. And okay, everybody hoarded and did some things. And into the toilet paper, people are saying, hey, we don't want inventory either. And they couldn't shut down. They stopped making some stuff. But I don't think it's ever been as bad where you can't get polycarbonate, ABS, nylon, polyethylene, polypropylene.
Oh my goodness.
PVC. I mean, the list goes on. I mean, there's very few and far between. So that's been my biggest job lately, is working with OEMs and molders to say, okay, I'm being told I can't get this resin. I can't shut down. I got to continue making something. What's your closest equivalent, or how can I get from point A to B? And sometimes it's, twice the price. But guess what? They got to do what they got to do to keep things moving. And sometimes maybe they're over-engineered or over-spec'd to where we could say, hey, you didn't necessarily need this. Let's try this. They try it. I'm working on a seminar right now called, single sourcing or double source, dual sourcing, where a lot of people were happy saying, hey, I'm buying this resin and it's the only thing on the print. Well, guess what? Now it's discontinued. I can't get it unless it's tested or approved. Now it's nice to have 3, 4, 5 things on your print. It says, I've tried this one, this one, this one, this one, this one, and just go down the line and you know what works and what doesn't work. The other thing is working with these engineers, they know what works, but they don't know what doesn't work. So I ask them, okay, do you need cold weather impact? Well, yes. Okay, what kind of cold weather impact? How cold? 0, -20, -40. Is it going to be in your area, Seattle versus Minneapolis, or is it going to be in, Canada or Northern Alaska?
Yeah.
We have different temperatures, different climates. So
it is. You bring a couple good points up in this about, engineers wanting to over engineer something by saying, hey, I want -60 degrees, because someone could use this
Yeah.
at the North Pole, right? But then you go back and that's too expensive. When he comes down the road, it gets too expensive and they go, oh, nope, we might have to cut it back a little bit to, minus 10 degrees or something like that. And you have to help them balance that with the best properties.
Right.
And that's really about technical sales, is really one of the things that differentiates it from selling a product that doesn't have that technical requirement. Your knowledge around it and your application knowledge is really key. So do you have specific lines that you cover, or do you have a broad spectrum and you have to zone in on each one when you're doing a different project for someone?
So the company I work for is a large distribution company slash formulator slash compounder. So we have access to pretty much anything and everything. I mean, I can get anything from PVCs to elastomers to TPU, polycarbonate. We have anything. And actually I just happen to have my little, a tanagram of all the different kinds of resins.
Okay.
Less crystalline. And this is what I kind of go through when someone calls me and says, hey, I have this and this. I look at this and I kind of run through the list to go, okay, if it's outdoor, what have outdoor properties? Well, my ASA is a weatherable polymer. My PMMA, my acrylics are made for outdoors. I can get some UV polycarbonate. There's different things. And so I run through scenarios in my head to say, okay, what kind of impact do you need? What kind of strength do you need? What kind of chemical resistance do you need? Then you start getting up the triangle pyramid. As you start going up higher and higher and higher, it costs more money, but you get more performance. So you can start getting more and more properties as you start going up that pyramid, but your cost starts to go up too.
Yeah.
And then we start talking about offsetting the cost by running thinner. Instead of running at, 100 thou thickness or 80 thou, which kind of was when we were engineers. I mean, if everything was like 80 to 100 thou, that's pretty normal. Yeah. Nowadays, I'm seeing a lot of 60 thou, 40 thou. I got stuff thinner and thinner, it's just more cavities and thinner wall sections. So
that's what I was going to ask you. So, in molding, what has kind of over the last 10 years, 15 years, what have you really seen in differences? Now you're saying wall thickness, thinning, and some other things, but what have really been some of the interesting things you've seen people producing injection molded parts are doing?
Officially nothing's really changed. It's always kind of been when I walked through Falcon Plastics the very first time, it kind of reminded me of growing up a kid with the Play-Doh Fun Factory.
Yeah.
You take some, you put it in the backside, you squeeze it for extrusion, or you take this piece and you jam it. I have some silly putty that I always do with or whatever else, but you can form it into a shape and you can do whatever you want. Or back in the day when we used to buy the model airplanes and they come with all these pieces and you cut them off and flash. And I'm like, wow, that's a terrible design because it's non-uniform wall, it's non-uniform flow path, and it's fishbone. There's flash everywhere. And they sell you the sprue and runner and you have to do it yourself. It's kind of got to where everybody is more critical on appearance. They don't want to see the gate. They don't want to see gate blush. They don't want to see appearance. Appearance is very, very critical nowadays. Back in the day, it was kind of more of a shoot and ship. Here's a part. How functional is it? And now it's got to look pretty. Nobody wants to have an ugly cell phone case or whatever else. And everybody's proud of what they have. So,
I've definitely noticed that. When you look at a molded part, you very seldom, you won't see any flow lines. You won't see where the gate's at a lot of time. They really spend a lot of time to design the parts so that they look good. And
then two shot. I mean, your cell phone case, even though you don't think a lot about it, I mean, there's so much that goes into these. They have a soft touch, and then this has got to bond to this. And so it's two shot. It's very, very thin. Because then they want the impact, they want the strength, they want water resistance. You need, all the different things. So everything's gone thinner, more aesthetic, two-shot colors. You're seeing
So the two shot, for people that don't know it, is basically you mold one piece and you take that piece and put it into the another mold, and you mold a second bit of plastic around it with different properties, correct?
Right. Two shot, you can actually do it where like the platen rotates or the mold rotates, and you don't even take it out and put it in. It just automatically does it. Shoots two different barrels, shoots the first shot, rotates, shoots the second shot, kicks it out. All the way to that, or two shot where you actually take one, mold it, you stack it, then you put it into the press another time, and then you shoot another one around it. Yes.
Yeah. That's
resins.
Two different materials, like you said. That's how you can get a hard center or a hard feature, and then the rubbery outside of like a phone case. It's a great example because you have the soft outside and a rigid interior. But interesting. So one of the things that I really have been interested in for my entire life. I mean, I can still remember when we were in molding, right? And we were working and the size of machines that we were working with were not really that big in the industry comparatively.
Right.
And now, cause I think we had like a 500 ton or something like that. And that's not the weight, it's different, but now they have like 5,000 ton machines or something like that.
Yeah. It's amazing. I'm not necessarily sure how big they are.
Yeah.
I worked on a 4 to 3, 3,000 is not uncommon. And your tonnage is the amount of pressure it holds between the clamp platens, and how much you can hold it together. So the larger the size, let's say you're making some bumper fascias for automotive or side-by-sides, flow path to wall thickness, it's all different. And it's all tonnage and pressures and speed. Technology is kind of the same. It's always kind of been the same thing. You heat up the plastic, you squirt it in, you cool it down and kick it out. But, the technology is changing now to where you use infrared cameras to determine the temperature of where it's coming out to optimize it. You're using mold flow simulations before you even put it in, to say, how's it going to flow in my mold? What kind of warpage am I going to get? You're doing predictive simulations. So prior to even getting started, how it's going to flow, how it's going to warp, and how my water lines are, and what kind of cycle times. Back in the day, we used to have to guesstimate. We look at something and go, hey, what do you think the cycle time is going to be? And
so that's probably one of the major technological upgrade or improvements over the last 10 or 15 years, though, is like the mold flow analysis, because you can really simulate pretty well now with the software.
Yeah.
Good. So I was funny because this last weekend we were, as I mentioned before we got on, we were at a place up in the mountains, and I grabbed one of these Adirondack chairs, the ones you kind of settle over, but it was a molded chair. And I always think of it, boy, that thing was in a big machine to mold one that big, a chair and people don't understand when you look at the bumper fascia of a car, what the tool behind that really looks like. And I've always been amazed at those things and what they do. But we're sitting here talking about molding and about tech support and application engineering with Sean Mertes at Amco Polymers. And, the one thing that I was going to ask you that I thought we couldn't get off without doing is, what's the most interesting application that you had to work on?
Ooh. The most interesting or the most fun? I don't know.
Well, either one. Tell me the most fun first of all, because that.
Well, fun. I mean, there's so much different things, but if it's something, like working on 4-wheelers and side-by-sides, we do a lot of stuff with guns. I remember back in the day, I think you even had your FFL license years and years.
Yeah.
And so now, working with guns and magazines and clips and different pieces. So I love working on things that I physically can use and utilize and do stuff. So, working with large OEMs on that is always so much fun. To me, it's seeing it from the beginning to the end and actually physically coming up with an idea. I've seen some stuff all the way from a paper napkin, to a design, to this, to a tool, and then it takes off. Some of those are probably the best, but
Yeah, so you're helping people across the board that are doing all kinds of different stuff, right? So you talked about UTV stuff. You're doing OEMs for cars. You're doing electronics applications. You're doing all different kinds of stuff, correct?
Oh, absolutely. Yeah. So some of them, like I said, when I see a good design, I always like to remember it. This is one that I carry around with me. And this is a living hinge. So it basically flips. It's got a little piece that goes on your belt. This is actually so you can put your earphones in and it puts your belt. But people don't think about, but the little piece of, you have to have steel in there so that plastic should go in there. But this actually has a living hinge that pops out. So it's an open and shut tool with two hinges that clips, snaps into place to create this little belt loop. The gate is down here on the bottom and it's subset. I mean, this design, I'm going to say, is 30 years old, but this cool design of how they made it work to lock into place, open and shut, it just, I've opened this and closed this probably 100,000 times, and it still works like a champ. I carry this around as a really cool mold design, part design feature that I see.
Yeah, when you see those things that the clever designs that people can come up with, like you said, from the napkin and then roll it into the product, and then ultimately some of these things, in molding, you can have tens and hundreds of millions of these things made.
Oh yeah. I mean, I'm looking at your headphones right there, and I'll bet how much plastic is on that headphone.
Oh, there's a lot. Yeah.
They're just, the sound quality that they have and the acoustics that go into it. That's the thing that probably amazes me the most is how many little things go into each design.
Yeah.
We both travel quite a bit, and I like listening to books on tape and different things. But one of them that kind of amazes me is they were talking about, I think it was called Malcolm Gladwell with The Tipping Point.
Yep.
He talks about like Sesame Street and how they weren't sure that, animated characters and real people and how kids would interact. But the one of them that they said, and it still strikes me weird because I never really got into it, that they said just goes into it like Blue's Clues.
Yeah.
One of the, like for getting kids to remember it. I remember Sesame Street, something shows up on a screen and then do you remember it and where you look and marketing and just appearance and stuff. And how much, like I said, how much really goes into making something that we don't even think about.
Yeah, that's true. That's true. It is interesting when you look at that, because it does really give you some appreciation for the amount of work that goes into these kind of things. Because that's I hadn't thought about that for a lot of years, but it doesn't matter what it is. It can be a simple little pen clip or the top of a pen. Actually, this is probably a really, really good example of how much thought you have to put in, because you got to make every little piece in this thing for next to nothing to be competitive. And so it's got to go super fast. It's got to be super reliable. It can never screw up. And you got to be able to make 100 billion gazillion of these things, and the tool can never wear out. And you just all the things that have to happen for most of the stuff that we do, because people don't realize that if I go home with my new whatever SUV and I've got an air cleaner on it or a component on it that's plastic, there probably were 500,000 of those made or more. And because it used on multiple models and used on everything else, and just that one little piece in your air system that pulls the air into your vehicle, a molded piece on there, the requirements around it, and just the design intent and everything that has to go into just that one little piece. When you think about everything we have, I mean, someone can walk into their kitchen now and look at 100 different things in your kitchen, and not even, I mean, even just a blender for your margarita on a nice sunny day.
Well, the picture about, or talking about is, just bread, the bread bag that goes to keep bread fresh. How many layers there are actually in bread or chip containers? You have your tie layer, your binding layer, your moisture layer, your oxygen layer, and I mean, we're talking how thin it is and how it is, but yet there's how many different layers that go into that film. And like I said, unless you actually stop and think about it or look at it, it can go right over your head and go, oh, it's just, how hard is this? Just plastic. But
Yeah, that is interesting. Yeah. So yeah. Yeah, I start to go back into that, and my head goes back into the days of designing stuff for people, and you do when you're making one of something, it's a lot different than making 100 million, that's for sure.
yep.
But so what are some of the things that you're excited for in the industry that you see happen, and you go, man, this is going to really be cool?
Let me think. The industry, even though it's changed so much, it's changed so incrementally. It's still the same technology. The only thing I really like is there's a point now where there's some new technology out there where it's kind of, they're saying, can you, basically everything before was you fill it as fast as possible, fill it 95 to 99% full, then you pack it and cool it, so on and so forth. There's some new technology out there that says, hey, maybe you don't have to fill fast. Maybe you can fill a little slower and get better, characteristics. And, they're just kind of starting to challenge some of the things that are out there. So it'll be interesting to see, do they really come to fruition or not? It's a paradigm shift. You have to switch. So now all these injection molding machines, do you have to get retrofitted to be new, or, some people are going to stick with the old. It's kind of like back in the day with the DVD player versus the Blu-ray versus what are those big discs or whatever else. There's three of them, I think, that were like, all right, which way am I going to go? Because which one's going to lead and which one's going to win?
Yeah. So are you seeing a lot more electric machines in the industry? I know those were popular and I know people are using them. But are those becoming more prevalent, or are the traditional hydraulic and clamp molding machines still the mainstream?
No, I'd say it's probably becoming more and more electric. Those electric servos are so repeatable. The problem is they carry a price tag with them.
Oh yeah.
Back in the day, I remember, especially you being plant manager down in Tennessee, you're responsible for building and buying brand new machines, so on and so forth. And nowadays, they have some stuff that comes from China and overseas, and you can buy a press for, under $100,000, and you can get a 300-ton press for $80,000. I'm making these numbers up, but it's like, holy smokes. I mean, they're almost disposable. Like these little four-wheelers that I see, when you go buy a brand new one, they can cost $4,000 or $5,000, but you can buy these little Chinese, Japanese one for $800. I'm like, how are they making it over there, shipping it here? The bad thing is they're cheap. After a week or two, something starts falling off and you have to replace it and, put duct tape on it. But they still built the tool. They still made it. And I'm just amazed how cheap things can get. I mean, cell phones, just what you're getting cell phones for now. And
it'll be interesting to see how that goes. All right. That's cool. Cause I was curious, but it is interesting because that industry was old when we got into it.
I know.
That's the one thing. It's kind of, it's been around me because you go back, they were molding plastics in the 50s. And
the funny thing is it is old, but compared to steel, compared to the other stuff, it's new technology. It's really truly new technology. I mean, we're 50 years into it. Iron and steel goes back to, I didn't even want to pretend to guess how old that technology is. And that's the thing that we're preaching now is part design. Everybody's like, oh, just make it thicker, make it thicker, make it thicker. It's like, no, the steel industry doesn't do that. They use I-beam, C-channels. They understand moment of inertia. And this is where my engineering background really helps out, because I remember from our statistics class that we took together in some of those classes, but, stiffness or rigidity is equal to moment of inertia times your modulus.
Yeah.
So I can have, and I don't know if I have it with me right now, but I did a seminar where they talked about a ruler. I take a ruler and I have it in the flat area. I can bend it nice and easy. I turn it this direction. I try to bend it and it's much more rigid. That's because my moment of inertia changed. So adding ribs, adding things. And that's where right now, the technology of strength and stiffness and how thin can you get and how fast can I fill it and sink. And it's boggling how things can be made so different. And
yeah, he's still evolving the industry with this many years, and the computers and the design capabilities and the modeling capabilities allow you to keep getting better and better and better before you actually go into the physical product.
Well, I think we're slowly starting to catch up to, the steel industry. Like I said, the I-beams and the C-channels and stuff. We've been doing it for years, but everybody was kind of just following along in plastics and doing what they were doing because it was working.
Yeah,
It's not broke, don't fix it. Until all of a sudden now someone goes, hey, wait a minute, I got to start worrying about cost. So I need to go thinner. I need to do this. I need to foam, using, technology where I can foam thin wall and I can foam a straw. That technology is new where you actually put, carbon dioxide or a liquid into the barrel and then it comes out as, a foaming agent as opposed to the foaming agent we used back in the day. So technology is always changing. There's, polymers are changing. We have some new grades here, which, can go down to -60, still maintain clarity, chemical resistance. Polymers are changing. I mean, it's still basically the same polycarbonate backbone, the same copolyester backbone, same backbone, but they're getting some different things, like we have a syndiotic polystyrene. So we have to get
you can't even say it.
Yeah.
You can't even say that word, man.
I know, it's tough.
Yeah, but so they're getting up with better additives to make the properties, the end properties of it more extreme, I guess, for lack of a better term.
And the new thing now, the new trend is green, bio-based. You know all about bio-based with your ethanol background, so on and so forth. But there's different things, biocompatible or biopolymers. Is it going to degrade or fragment? And does it come from oil or does it come from natural sustainable resources?
Yeah.
Does it disappear? And if it disappears, does it disappear in 60 days, 90 days, a year, 10 years, 20 years? End of life cycle. You have your PLAs and PHAs and so many different.
Yeah. Because there was actually somebody that I was talking to. Well, I still know him, a guy from California that's developing cosmetics that are in bottles that the bottles degrade over, I don't know how long, over 9 months or 6 months or something like that once they're in a landfill, and something to do with the additives and the way that they process the plastic when they're making it that allows it to do that. But yeah, that's interesting too, because that is some of the things in the sustainability, the reuse of plastics and the making them be able to degrade is probably something you get a lot with the more disposable kind of applications.
It is, but watching stuff, it gets to be a tricky business too, because you could take a disposable, degradable cutlery.
Yeah.
And then if you want to take normal cutlery, you can't tell the difference between a disposable, degradable cutlery and normal cutlery. So you take it and you want to do post-consumer. So you go in and you start pulling all these different cutleries out. Now you start blending and mixing. Well, now I contaminated my styrene with PLA because you can't tell the difference between a PLA. Nobody's looking at the numbers. Nobody's looking at the you can do some stuff on density and float it out, but it gets to be, now you start putting some stuff in your recycled stream, and now you just contaminated this, and now things that aren't supposed to degrade are going to start to degrade. It's a tough road for us to get.
It's a tough nut to crack. It's a tough nut to crack, but we're going to have to crack it sooner or later, because I think that you're right though, because old school, you had to keep everything absolutely right. Hopefully they've figured out better ways to do it now, so at least on some of this where you're trying to recycle. But you're exactly right that if I stick this plastic pin in a bunch of milk jugs, I just contaminated all the milk jugs, because this plastic isn't anything like the stuff that's in the milk jugs.
Well, that's just it. You think about the top of the milk jug is, the milk jug's made out of polyethylene, the top's made out of polypropylene.
Yeah.
It's a little safety ring on it that doesn't come off, and now it's got to be separated when they grind it.
Yeah.
The water bottle, same thing. The water bottle is made out of a different thing than their cap. Then they have a liner in there.
Yeah.
All the printing on. Yep.
Yeah, that's a good point. So recycling is going to be a challenge, or it has been for a long time, and hopefully we got some smart people working on that. They're going
Absolutely.
to figure that stuff out. I'm sure there's a lot of smart people working on that, but
Oh,
yeah, you got a lot of they're doing that. So Sean, what's up with you for the rest of summer, man? What's planned? What are you going to do?
well, we've been bought a toy hauler, so
Yeah.
actually just a little camper that I can throw the
Yep.
Harley in, and we're gonna go to Sturgis here in 20 some days. So that'll be a
Nice.
lot of fun.
Nice.
We're just talking about going to outdoor concerts. I mean, without COVID now, it's nice being
Yeah.
able to get out and be around other people and,
Yeah.
venues and do different things. The state fair is going to happen, Renaissance Festival. We've had phenomenal weather. It's been dry, so the farmers haven't necessarily liked it, but it's been mid 80s and
Oh, nice.
sunny
Nice.
days.
Good stuff, man. Good stuff. Well, it's been awesome to have you on here, Sean. And as it usually does, our time is we could sit here for hours, but we got things that we're going to get done after this. So awesome. So thankful to have you here. And for those people that want to reach out and get a hold of you, is LinkedIn a good place to get a hold of you?
Yeah, absolutely. Yeah. LinkedIn. I check my LinkedIn. I have some subscribers or followers, so on and so forth.
Yeah.
So
very good. So Sean Mertes, Amco Polymers. If you got any questions about plastics, like I said, he's been in this a couple weeks now, so we'll we'll be, but he can help out there, and we'll have your contact information or the company and your LinkedIn profile in the show notes so people can see that when we get that put up. But thanks so much for being here, Sean. Really appreciate you stopping by the Faces of Business.
Absolutely. Thanks for having me, Damon.
All right, man. Everybody else that's listening, we're going to be back here on Thursday. We're going to be talking with another interesting person about business and what they're doing and just kind of sharing with the people in general. So come on back again and we will talk some more. Thanks everyone for joining us today.